Hi, Chem 11. So just finishing up the lab, moles of copper and iron. It's a bit of a slow lab for getting a reaction finishing, but I thought I'd just get it done for now for the end of the day. So what I've done is this. I allowed the reaction to complete. What happened as after I'd added the iron nails to the copper chloride solution was we started to see the iron changing color to brown. In fact, what's actually happening is crystals of copper are forming on the iron, and iron ions are going into solution. This is what's called a single replacement reaction. So you might remember single replacement reactions from Science 10, where you have a more reactive metal that is in an elemental form, and there is an ion that attacks it that's in solution. The ion which attacks it itself becomes a pure element. It gets electrons from the element that is that you start with, and then so you have they switch places. The atom that was in the elemental form is in the ionic form. The atom that was the metal that was in the ionic form ends up in the elemental form. So the elements here are copper and iron. We start with iron entering solution to become iron ions, being replaced by copper, which becomes copper metal. In terms of the final results, it took a while, but here's where things ended up. Things you need to know. So the final the solution, I wish I'd taken a better picture of it, was kind of a bluish green color, which doesn't match perfectly that was more of a deep sky blue color we started with, and it ended up being a more bluish green color, which is the color of iron 2 salts. But at the same time, we did start with some copper salts, and there's other evidence to suggest that there was still some copper left over, which I'll get to later. The mass of the nails dry was 4.12 grams. The appearance of the sediment, well, I put down a dull copper brown. In reality, if you were to look through a microscope, it would be a lot more exciting than that, because what's actually been created here are crystals of metal, crystals of copper metal. Microscopic, but they're still in the crystalline form. This is the purest possible form you can have of any metal, is its crystal form. It's not to say that there aren't some contaminants there, but we have made pure elemental copper. The filter paper I used weighed 0.58 grams, and the combination of the beaker with the filter paper and my final dry copper sediment after I dried it off on the hot plate was 70.46 grams. Subtract all of these and you end up with 2.46 grams of the 2.46 grams of copper sediment. Yeah. So what this allows us to do is to calculate some chemical amounts. They're written up right here. I'm just going to let you look at those for a moment. I have to do a quick calculation. Okay. No, we're all good. So, to review, the copper 2 chloride dihydrate, I calculated the molar amount, the chemical amount. This is something you should be able to do by this time. Take a mass that you're given of a substance, divide it by a molar mass, which you can figure out yourself, or in this case, it was on the box, on the container, and get a chemical amount. 0.0501 moles. This means that there's 0.0501 moles of the copper ion available that's part of that whole copper 2 chloride compound. 0.0501 moles of the copper were available to do the reaction. When I first did this, I left it overnight. This time, I only left it for a few hours, so I don't think it all reacted. Here's what happened with the nails. 6.36 grams to start, 4.12 grams at the end. A 2.25 gram mass loss. Same thing, we can calculate the chemical amount, and this is easy because you just use the figure from the periodic table. 2.25 grams of iron divided by 55.845 grams per mole of iron gives you 0.0403 moles of iron that were used up in the reaction that went to become iron ions. How about the copper crystals? I already told you that calculation right there, the 2.46 grams. Same thing. We can now calculate the chemical amount of copper. It's that 2.46 grams. You're dividing it by the molar mass of copper. You get that from the periodic table. And here's the figure I get. 0.0387 moles of copper that were created, those little copper crystals. So what's our ratio? Because this is all about ratios. We could do this in a huge amount or a tiny amount. It's the ratios of masses of chemical amounts that are important here. And in fact, it's pretty close. I'll be honest, I'm a little disappointed it's not closer, but it's actually not bad. We have 0.0387 copper to 0.0403 of iron. In other words, this is about 0.96. Not a whole number ratio. Let's examine the possible ratios we could envision at the start of the experiment. There are two candidate reactions. Either you're making iron 3 chloride or iron 2 chloride. In the first chemical candidate reaction, copper 2 chloride, 3 units of it, reacts with 2 moles or atoms of iron to make 2 iron chloride and 3 copper. The ratio for this would be 3 to 2. We would have a fraction of 1.5. When I say 3 to 2, I mean 3 copper for every 2 iron. 3 moles copper for every 2 moles of iron. That fraction I calculated down there would have a value of 1.5. And clearly, 0.96 is pretty far from 1.5. How about the second possible reaction? Well, here we're taking our copper 2 chloride, combining with iron in the nails, creating iron 2 chloride and copper. We don't have to worry about ratios here. Well, we do, I guess, but it's easy, isn't it? Because there's no coefficients. The chemical equation has no coefficients. In other words, everything is 1-to-1. The prediction here is that the moles of copper and the moles of iron should be equal to each other. To evaluate what we have here, well, our 0.96, it's below that figure of 1. So there's really no evidence at all that we've made any iron 3 chloride. The only evidence is that we're making iron 2 chloride. So those are all the results you really need to know to use the lab. I thought there's 2 other things I would do that are of interest to me and maybe will be to some of you. First of all, I asked the question, hey, have I used up what's happened with the copper? Is there copper left over? Have I used it all up? And here's how that plays out. I took some of the remaining copper solution, and it looks like this. I was a bit surprised by this, but what did actually happen that I wasn't thinking this through perfectly is I poured out a lot of the solution that had a lot of the iron in it. I think a lot of the iron precipitated. So I did take some of this solution here, and this is a copper solution that we have right there. And I put a nail into it, and lo and behold, look what's happening. The same reaction all over again. The nail is getting encrusted with copper. So in other words, there's still some copper left over in solution because these crystals of copper are growing on the nail and corroding the nail just like before. This is going to happen a little more slowly because there's not a whole lot of copper left over, but there's still enough to make the reaction happen. Something I thought I'd try just for fun really is do a little comparison. Now, yeah, we're 9 minutes in the video. I'll show you this way. So to me, this is interesting because I'm still asking the question, is there any evidence that there's any side reactions? Were we only making iron 2 chloride, or was there iron 3 chloride in the mix? There's a way you can find that out, at least get some hints about it. And that's using an indicator chemical to figure out, do you have iron 2 or iron 3 ions that are present. The indicator chemical I have in mind, and I don't know if this is going to work, so whatever, we'll see if it works, is potassium thiocyanate. It's this stuff right here. This isn't part of the lab, this is just out of personal interest, and maybe you'll be interested too. Potassium thiocyanate is very interesting. It's a polyatomic ion you might not have heard of, made of a sulfur, carbon, and a nitrogen, and it makes this very harmless looking or normal looking clear solution. It's interesting because thiocyanate ions form complexes with certain other metals, and you get colors from that that indicate which metal is present. A signature indication you get with the thiocyanate ion is it has different shades of red that you get when it forms complexes with any iron 2 or iron 3 that might be present, and it also forms a characteristic complex color with copper in solution. So I thought, hey, let's just try it and see what happens. So I have 4 solutions. First of all, there's this solution right here. I'm going to use this. I'll take the nail out. This solution here is ferric sulfate. Ferric sulfate is iron 3 sulfate. I don't have the chlorides. This is ferrous sulfate, iron 2 sulfate. And this is the unknown solution that I have that's left over after the reaction. Probably that last blue solution is mostly a weak solution of copper 2 chloride. I'm going to add some of the potassium thiocyanate to each of these vials, to each of these test tubes. This one is the one where I just repeated the reaction in. This is the iron 3 solution. This is the iron 2 solution. And this is the leftover solution from the reaction that is probably a mixture of different metal ions in solution. So here's what I get when I add some of that to the potassium thiocyanate to the reaction mixture that I was just working with. So that's the color right there. A little hard to read that. Looks like it's opaque, so we have some precipitate in solution. So this is an example of what we should expect for whatever is the product of the actual reaction. Now I'm going to add potassium thiocyanate to the iron 3 sulfate. Blood red. Often this material, this thiocyanate complex with iron 3, is used as stage blood. It's transparent only if you add this to a lot of water. This is a very deep, bloody red color. And look at this. Nothing. This is the result of adding potassium thiocyanate to the iron 2 sulfate. Combining potassium thiocyanate with the iron 2 ion, we have no color change. Now I'm going to add to this unknown mixture that is what was produced in the reaction. So realistically, again, this is going to have a mixture of some kind of iron salt with any leftover copper. We have a similar result. It looks like there's a mixture. I think what we get here is a bit of a mixed message. We see it's very distinctly different. If you have a pure iron 3 salt, blood red. If it's a pure iron 2 salt, no color change. The product of the reaction here, after I think we've removed most of the copper salt, here after there's still some copper salt left, they're pretty similar. The one thing I was possibly expecting was for this to turn black, because when you combine copper 2 salts with the thiocyanate, at least internet tells you that it should go black. It looks like that's not the overwhelming effect here. That effect of combining iron with that is still pretty overwhelming. My opinion is what this shows us is that at least some iron 3 salts are being created in this reaction. But given the difference in the shade and the possibility of some contamination with the copper 2, I can't say that with a certainty, only to suggest that we're certainly not seeing nothing. We're seeing some kind of evidence of some kind of an effect. So I think this you'd need to see some further results for this. That being said, the ratio of 0.96 suggests that the overwhelming reaction, the reaction that was mostly happening, was the one that was reaction 2. Iron plus, copper chloride plus iron makes iron 2 chloride plus copper. I hope that helps, and that little last part didn't distract as much as it might have done, but I think it's useful to kind of, when you have a question that's not totally resolved, to try and work with it a little bit further. Be thinking about knowing how to calculate chemical amounts, understanding what is meant by a molar ratio, and working on those sources of error to complete this lab report. I hope that helps.